Welcome to Algebra 2 with Trig. Today's lesson is 1.4, slope and graphing a line. Why was the math book unhappy? Too many problems. So after this lesson, you'll be able to use the slope formula and graph a line given a slope and a coordinate. Okay, so in a coordinate plane, the slope of a line is the ratio of change along the y-axis to the change along the x-axis between any 2 points on the line. So what we're saying here is as we move up this path, right, we're going to rise up and there is going to be a run. So the slope formula, m, we always use the letter m for slope, of a line contains 2 points with coordinates x sub 1, y sub 1, and x sub 2, y sub 2. And it's given by the formula m is equal to the y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where x1 and x sub 2 cannot be equal. So there's a lot of stuff going on there. So what this is basically the change in y over the change in x. Change in y over the change in x. And we do that by subtracting the values. So the ratio of change in a y coordinates and the corresponding change in the x coordinates. So again, the formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which we can put in shorthand as delta y, change in y, over change in x. Okay, which is another way of saying the rise over the run. So you'll see here that we have a slope going up as we travel from left to right along this line here. So we would call that a positive slope, right? So as we move from left to right, we go up. Here we have a negative slope, so as we move left to right, we travel downward on the graph. So this is a negative slope. So as we go from left to right, we go down. This is known as a zero slope, or you might say no slope. Okay. And as we travel from left to right on this graph, you can see here that we are not moving up or down. So there is no movement up or down as you go from left to right. Undefined slope, okay, in this case, we don't move from left to right. Right? But we go both up and down simultaneously. That's why it's undefined. Okay, if this is going to positive infinity and this is going to negative infinity at the same time in the same place, that's why it's undefined. Okay, so given 2 points, draw the segment that connects the points and find the slope of each line. So we've got these 2 points and we're going to draw our segment. So just connect your dots. Now it helps to have our coordinates, so we're going to put those in 2, 1, and this coordinate here is at 6, 7. And I want to show you that the slope can be found no matter what the order. So we're going to call this point A, and this one's point B. And so we're going to find the slope as we travel from A to B. Now, as we go from left to right, we should see this as a positive slope. So let's go ahead and put that in. We're going to say, okay, y minus 7. 1 minus 7, excuse me, not y minus 7, the y values. So 1 minus 7 over 2 minus 6. And we end up with 1 minus 7 is a negative 6, and 2 minus 6 is negative 4. And positive over positive, or negative over negative is positive, and 6 divided by 4 is equal to 3 over 2. So our slope is 3 halves. Now, we can look here and we can see, will we get the same answer as if we go from B to A? So this would be 7 minus 1 over 6 minus 2. And again, we get 6 over 4, both positive, which reduces to 3 halves. Okay, so the order really does not matter, okay, for this, whether we go from left to right or right to left. Okay, here we have our 2 points again. Let's put our coordinates in. So this will make point C for kicks and giggles. And this is at negative 5, positive 7. And this point is D down here. And we're going to say this is at 4, negative 8. And we draw our segment. So we're going to go ahead and we'll just go from C to D because I just feel like doing that one today, right now. So we're going to subtract 7 minus negative 8. Notice I put negative 8 in parentheses because this helps eliminate mistakes, over negative 5 minus 4. So 7 minus negative 8 becomes 7 plus 8, which is 15. And negative 5 minus 4 is negative 9. So this value is equal to negative, each of these divide 3 out, and we have negative 5 thirds. So my slope is negative 5 thirds. Okay, we have another one here. So we're going to call these E and F. Okay, so point E is at negative 4, negative 7. And F is over here, and that's at 3, negative 1. And we draw our segment. And we'll go ahead, and this time we'll go the other way. We'll say the slope of F to E. And I do this so that I know, it just helps me keep track. So, negative 1 minus negative 7 over 3 minus negative 4. And we may want to just rewrite this again as negative 1 plus 7 over 3 plus 4. And we end up with negative 1 plus 7 is 6, and 3 plus 4 is 7. So our slope is 6/7. Okay, so let's talk about what happens when we go from a discrete set of data points to a segment. So this was from our first problem. We had solved this before. Our slope was 3, 2. This point here was at 2, 1, and this point here is at 6, 7. So our domain is just our x values. So we put this when we have a discrete set of data points, we just put it in set notation, right? So this is going to be 2 and 6. And our range is going to be 1 and 7. Okay. Now, something interesting happens when we draw our segment. Our domain now has to include all these different values, all these fractional values between 2 and 6 for our domain. So we're going to have to use our inequalities. So this would be 2 is less than or equal to x, which is less than or equal to 6. We could just take our original points in the domain and graph all the ones in between. We could use interval notation, which is even easier to write here. We just take 2 and 6 and put them in brackets. Our range is our y values again, so it's 1 less than or equal to y, which is less than or equal to 7. So our range would be just 1 to 7. Okay, so again, we're back with this graph, identical to the second one we did, and we're at negative 5, 7 for our first point, and our second point is at 4, negative 8. Again, our slope was negative 5/3. So let's go ahead and chart our domain here. So our domain with these discrete points is from negative 5 and 4 for the x values. Those are our 2. And I like to put these in numerical order. So this will be negative 8 and 7. And there's a reason for that you'll see in a second. So now we draw our line segment and our domain changes. This becomes negative 5 is less than or equal to x less than or equal to 4. And in interval notation, just negative 5 and 4 in brackets. The range is negative 8 less than or equal to y less than or equal to 7. And again in brackets, negative 8 and 7. Okay, so our slope from this one again was 6/7. So we'll just put that right there. And we're going to list our domain and range. So this is at 3, negative 1. And this is at negative 4, negative 7. So let's list our domain. Negative 4, 3. And our range is from negative 7 to negative 1. Once we have our segment now, it does, like I said, now we have an inequality. Negative 4 less than or equal to x less than or equal to 3. So this is going to be negative 4, 3. The range would be negative 7 less than or equal to y less than or equal to negative 1. And again, it's negative 7 and negative 1. Okay, let's graph the line given a point and a slope, and then find the domain and the range of the line. So the first thing we do, we always plot the point. So we're going to do that at 0, 2. Next, we go ahead and we plot a second point based on the slope. So if our slope is m is equal to -2, well, in fractional form, that's -2/1. So now we have our rise over our run, right? We go down 2/1. So we're going to plot that point, and then we connect our dots. We draw our line. Now you'll notice we put arrowheads because this is a line. So it goes on forever. So what's our domain and our range? Well, our domain is -infinity to +infinity. Another way of saying that is all real numbers. That's the symbol for that. Our range is, again, -infinity to +infinity, or we could just say all real numbers. So here's a caveat, or what we might call a rule, that for all non-vertical or non-horizontal lines, the domain and range are always, oops, get a Y in there, -infinity to +infinity, or all real numbers. Okay, let's go through this process again. Slope of 5, 4, that passes through -3, -2. So we go to -3, -2, and we plot our point. Our slope is 5/4, so that means we're going to go up 5 and 4 to the right, and that's going to put us right there at 1, 3. And from that point, we can, or at this time, we can connect our dots and draw our line using a straight edge. Okay, now our domain, we've talked about this. Our domain is -infinity to +infinity, or all real numbers, and the range is the same. Okay, slope of 1/3, that passes through 0, -5. So we go to 0, -5, put a point. Our slope is 1/3, so we go up 1, 3 to the right, plot another point, and then draw our line. Again, the domain hasn't changed. The rule hasn't changed. It's not a vertical or horizontal line. Therefore, it's -infinity to +infinity, or all real numbers. And the range is -infinity to +infinity, or all real numbers.